The number system we are using today has what we call a place value. As against, if you compare the Roman number system, which has no place value. For example, 3625, we have 4 digits in this number. Each digit represents a certain value depending on the digit as well as depending on where it is. For example, 5 represents 5 ones, 2 represents 2 tens, is 20. 6 represents 6 hundreds and 3 represents 3000. All these place values 1, 10, 100 and 1000 are powers of 10. So going from right to left, the place value increases as the power of 10. So let me mark them. 5, 10 to the 0. You know any non-zero number to the 0 is 1 always, so we can write 5 as 10 to the 0. 2 is powers of 10 to the 1, 6 is 10 squared, 3 is 10 cubed. So we call the number system we are using today as base 10. There's nothing wrong with changing the base to anything we like. Any number greater than 1 will work as a base. For example, we have base 2, binary numbers used in computers, and base 16, a lot of different bases. So here's a number written in base 7. The way we write it is, we write the digits and as a subscript, we write the base in letters. So the question is, write this as a regular number or write it to the standard base. Anytime you see the word standard base, that refers to base 10. So now taking some inspiration from what we have earlier, first place, the first rightmost digit, in this case 3, represent ones. 5 represents base to the power 1. Earlier it was 10 to the 1. Now it's going to be 7 to the 1. 2 represents our base squared. 7 squared. So these are the place values of my numeral for each of the digit. So 3, 7 to the 0. Again, you can write 1 as any non-zero number to the 0 power. So we keep changing it for any base. You can write it just as 1 or 7 to the 0. 5 represents 7 to the 1s and 2 represents 7 squareds. So all I have to do is calculate 2 times 7 squared. Just like 3 times 1000 cubed earlier, 2 times 7 squared is the place value of 2 in our new numeral. Plus 5 times 7 to the 1 plus 3 times 7 to the 0. So 253 to the base 7 is 7 squared times 2 plus 7 to the 1 times 5 plus 1 times 3, which gives us 136. An important observation, for base 10 I only need 7 symbols, 0, 1, 2, 3, 4, 5 and 6. You don't need 7 as a symbol to write anything in base 7 because 1, 0 to base 7 is actually 7. Let's try the same thing we did earlier. So 1, 0 to base 7 would be 0 ones plus 1 group of 7, which gives us the regular number 7. So again, as a rule of thumb, if you have a certain base, if base is 8, you need 0 to 7 numbers, 8 symbols. If base is 16, you need 0 to 15 symbols. Similarly, for any base, you need exactly that many symbols to write a number in that base. Let's talk about base 16. From our earlier discussion, we should have 16 symbols, 0 up to 15, to write anything in base 16. So we need 0 through 9, we have the regular numbers. 10, 11, 12, 13, 14 and 15, we cannot use 2 symbols to represent any of these numbers. Here's the problem. Let's say you want to write 10 in base 16. If you use this for base 16, it is not 10. It's actually 1 times 16 plus 0, which gives you the regular number 16. So you see, there's no way you can write anything between 9 and 15 if you do not introduce new labels. You cannot use two labels to represent any number up to 15. So what we do is we introduce English letters A, B, C, D, E, and F for 10 through 15. So A is 10, B is 11, likewise. So here's an example. Write the numeral F3D. This is no different from what we did earlier except for the new symbols F and D, and we know their values. F is 15, D is 13. So all I need to do is simply replace those values. Remember, this is a numeral with 3 places. It's a common mistake when some people change it from these labels to the regular numbers. They automatically think it's a 5-place number. No, it only has 3 digits. So first digit is F times the place value is 16 squared. The base is 16 going from right to left. D is ones, 3 is 16, and F is 16 squared. So F times 16 squared plus 3 times 16 plus 1 times D. Now I'm going to change F and D with the actual values. 15 times 16 squared plus 3 times 16 plus 13, which gives me 3901. What we did earlier is, given any numeral in a different base other than the standard base, we went back and wrote it in the standard base. Now it's the other way around. We have a number 455 given in the standard base, base 10, a regular number. We have to write it as a numeral in base 6. So this is a little bit more involved than what we did earlier. First job, we need to find out the largest power of 6 in 455. We compare the number with successive powers of 6. So 6 to the 1, you don't need to necessarily start with 6 to the 1. 6 squared is 36. Still our number is bigger than 36. 6 cubed is 216. 455 is still bigger than 216. That means it's possible we could have 6 cubes. 6 to the 4th is 1296. We can never have any 6 to the 4th in our numeral because 6 to the 4th is bigger than 455. So we have to start with 6 cubes. What we are going to do next is keep separating 455 into groups of 6 cubes, 6 squares, and 6, and finally ones. In the process, you need to be familiar with integer division. So the largest power of 6 is 6 cubed in our number. So we are starting with 6 cubed, which is 216. We divide 455 by 216. We get 2 216s, and the remainder is 23. Again, the idea is there should be 2 6 cubes in my number finally, and now I need to work on 6 squareds, 6 to the 1, and 1s. So I take 23 and try to divide it by 6 squared. So obviously there are no 6 squareds into 23. Result, quotient is 0, and still I have all of 23. So now I'm dividing 23 by 6, result is 3, 6 times 3 is 18, 5 is left. So if you carefully look at what it says is there are 2 6 cubes, no 6 squareds, 3 6 cubes, and 3 6 to the 1s, and 5 1s. So now we can write the number 2 6 cubes, 0 6 squareds, 3 6s, and 5 1s to the base 6. Again, if you try to go backwards and write it as a regular number, you should add 5 times 1 plus 3 times 18 plus 0 times 36 plus 2 times 216, which should give us 455. Another thing to remember is we knew 6 cubes are in our number, and from their right from this step, we can figure out how many digits there are going to be in our final numeral. 6 cubes, so we should have something in the place of 6 cubes, 6 squared, 6s and 1s. So our final answer should be 4-digit numeral.